Hi guys, my name is Bruce. I'm a senior data scientist from ZEFR. We're a company located at Marina Del Rey in West LA, and we do video level contextual targeting on YouTube and Facebook. Today I'll be mainly talking about what's machine learning for contextual targeting, and specifically how ZEFR does machine learning for contextual targeting. Before I go into my formal speech, please let me introduce myself. My academic life was spent mostly on mathematics and statistics. I got a bachelor degree in mathematics and statistics from Purdue University. And then I went to the graduate school of University of Washington at Seattle, where I got my master in statistics. In terms of working experience, I have worked on large-scale recommendation systems. Specifically, I developed large-scale candidate generation algorithm for recommendation systems. And I also have experience in natural language processing and natural language understanding. At ZEFR, my main responsibility includes two parts: machine learning modeling, which includes text classification, time series forecasting, or sorts of model diagnostic, and engineering works, including infrastructure maintenance and development of our internal distributed machine learning pipeline. So let's get into topic. I would like to talk about a little bit on contextual targeting. What is it and why it matters? So first of all, what is contextual targeting? Contextual targeting basically is a way to do advertisement, especially video advertisement, in a way that you focus more on the alignment between the content of the media and your ads, instead of focus on the alignment between the user information and your advertisement. Why it matters? I would like to illustrate this from two perspectives. The first one is that if you target the wrong content, the result could be catastrophic. CNN has reported that it found ads from over 300 companies and organizations on YouTube channels that are promoting Nazis, pedophilia, conspiracy theories, and North Korea propaganda. These ads come from big companies such as Facebook, Netflix, Hulu, Under Armour, all sorts of big brands. And this brand has started feeling increasing concerns about brand safety issue on YouTube, so they've started boycotting their campaign for YouTube to run advertisement for them. The other perspective of why content targeting matters is that when you target the right content, it's very beneficial for a brand. For example, a study done by IPG Media Lab, which is one of the world's largest media group, has shown that among different targeting strategies, which are video level contextual targeting, user demographic information targeting, and YouTube channel targeting, video level contextual targeting is the most efficient way to reach out for a brand to reach out to their consumers and customers. And Oxford found that high energy commercials, which aim to be active, exciting, and arousing for viewers, has become increasingly widespread. In fact, on just Hulu, Oxford found that boisterous ads made up 80% of all the commercials that were shown on video on demand devices. Now, we should at least realize that contextual targeting has become more and more important, and there are more and more needs from brands on brand safety issues and contextual targeting needs. And it makes sense for us to at least make assumption that every brand cares at least a little bit about the content their video ads run against. So that's where ZEFR comes into business. We help our clients, our brand, to do contextual targeting in a better way by capture their brand preference. So for example, when a company or when a brand come to us, we'll capture their brand preference by listening to their business requirement, what target they want to be around, and then we'll translate their brand preference into data for our algorithm and model to learn signals. And once we have those signals, we use the signals to find the most suitable content to match brand preference, and we active campaigns on different video platform advertisement system, for example, Google AdWords or Google DV360. Now you may wonder what brand preferences look like, and here I will give you some specific example of brand preference. The first one is that a pharmaceutical company come to us, said that they want target health and wellness concept on YouTube, but they want to be away from new age medicine. The second example is that an alcohol brand come to us, said that they specifically want to be away from videos that primarily intended for children to watch on YouTube, because drinking under 21 is illegal, and promoting alcohol consumption for children will hurt this alcohol brand's reputation in the industry. The third example is a shoe company that comes to us that said they want target NBA videos. And the last one is a little bit extreme but not impossible. That is, the CEO of a company for example, has a personal beef with Jimmy Fallon, and thus he wants all his content to be away from Jimmy Fallon's show or Jimmy Fallon's video. So now you kind of have a rough idea what brand preference look like, and I will talk about how ZEFR turned that into signals for our algorithm and model to capture those brand preferences. We've tried unsupervised learning method to discover metadata patterns from videos, but we found that it's not quite successful because the output by unsupervised learning models changes all the time, and we cannot guarantee that the output by unsupervised learning models can capture brand preference well, because it's really hard to incorporate those signals from brand preference into unsupervised learning models. We have keyword search like YouTube does. We can do complicated keyword search. We can combine keyword search with all different kinds of sourcing targeting strategy. We also have inclusion and exclusion list. Basically, is a simple strategy where you include or specifically filter out videos or YouTube channels or YouTube influencers that you want to target or you want to be away from. But the two solutions in the middle are static solutions. That is that once you define your word search, it's static. And once you define the inclusion exclusion list, it's static. But the content on different video platforms drifting all the time. A word today might have totally different meaning tomorrow. So if you have static solution, you cannot capture those dynamic drifting content. Thus, we wonder if it's possible to develop a supervised learning algorithm to dynamically capture the brand preference so that we don't have to spend a huge amount of human effort to maintain keyword list and inclusion and exclusion list. But the problem we're facing is that when we are provided with video metadata, we only have information about the video. We do not have the user information. That is, we don't know who watched the video, when they watched the video, what's their reaction on the video, when they watch, whether they click the ads or they view the ads. We have no user information. So usually for a regular recommendation system, you need the user information part to form a closed loop to train your model, to train a machine learning model for free, right? But we don't have that part. So that basically means we don't have training labels. So we have to figure out a way to generate labels to train a supervised model. Then we developed a process called human in the loop at ZEFR. Basically, we leverage human effort to review videos and answer surveys for us to generate machine learning labels to train. For example, if you think about the pharmaceutical brand I mentioned earlier, essentially we want to find a set of videos that best suit the health and wellness concept for the pharmaceutical company, right? And if you repeat this question many, many times in your head, it's like when you look at the video, you wonder, is this video about health and wellness concept? And this essentially is a form of survey, right? You want to ask different questions about this video. Is this video about this concept? Is this video about that concept? So our solution is that when brand comes to us and illustrate their brand preferences, we'll turn their brand preferences into a survey that consists of different questions. And then we'll gather a bunch of videos together with the survey and feed it to cross-sourcing platforms and ask reviewers from the cross-sourcing platforms to review videos and answer questions for us. And once you have the questions, question and answers, you can generate machine learning training data to feed to a machine learning model, right? And once you train a model, the model can predict on whatever video you have, and the model can know how certain it's about a video, whether the video is about this concept or not. And you can find the set of videos that the model is most uncertain about and feed it back to the cross-sourcing platform to do another round of review, right? And essentially, if you look at this diagram, it's an active learning pattern, right? And if you do this iteration several times, you will end up have a model of decent quality. So you may wonder how the data looks like. Here is an example. For this video, assume that we have 3 different brand preferences: health and wellness, cooking, and sports. We ask this video against the 2 of the concepts. The first one is health and wellness, and the second one is sports. And it's marked by the reviewer as a positive example for the health and wellness concept and a negative example for the sports concept. For the cooking concept, we never asked the question for the cooking concept for this video, so it's marked as unknown. And if you expand this data frame to a larger data frame, since we have tens of millions of videos and we have many concepts, and for most of the videos, we only ask it against 1 or 2 concepts, right? Then essentially, this data set on a large scale will become a sparse multi-class classification data set, right? Where you have only a few of your label columns to be present, and most of them are missing, which is unknown. Unfortunately, we haven't found any good strategy to directly modeling on this multi-label classification sparse data set, because you don't know whether, if you imputed all the missing label with 0, it doesn't make sense, right? Because this video, even though you didn't ask cooking questions for it, it could be related to cooking question, right? So naively imputed labels with zeros doesn't make sense to us. So we have to figure out a way to turn this sparse matrix into some dense matrix that we can learn on. The solution we come up with is a process called binary reduction, multi-label to binary reduction, where this data set, the multi-label classification data set, will be turned into binary rows where each rows can be interpreted as, is this video about this concept? And the label is a true or false, right? And for example, for this video, since we only asked it against the two of the concept, we ended up having 2 rows. This video is a positive example for health and wellness concept and is a negative example for the sports concept. And the cooking concept is gone because we never asked the question against that video. By doing this, we're able to turn this sparse multi-label classification data set to a dense binary classification data set. Next, I would like to talk about some of the featurization process. On the text processing part, we're heavily using word vectors, where each word is embedded with a vector representation in a lower dimension so that semantic meaning can be captured by combining the vectors for different words with different mathematical expressions. And specifically, we're using the GloVe embedding released by Stanford, which is trained on 6 billion tokens on Wikipedia. We are also training our own word vectors on our YouTube corpus because we think that there fundamentally exist differences between language patterns on Wikipedia and YouTube. For computer vision part, we have a ResNet as our feature extractor. Basically, we will feed video images into ResNet and we extract the feature output by the last fully connected layer and use it as features for our video images. The model we use is called LightGBM, which is pretty similar like XGBoost, is a gradient boosting tree that incorporates second order derivative information during gradient descent. And the advantage of LightGBM over XGBoost is that when it tries to node split to build decision trees, it doesn't go, at each level, it will find the node that has the most entropy to split on instead of go over all the nodes at the same level and split on all of them. So that it's faster to split because you only split on the node that has the most entropy, and it's consumed less memory because you don't have to split on all the nodes there. We use scikit-learn as our featureization pipeline, and we do hyperparameter tuning like random search, gray search, together with cross-validation to find the best parameters for our model every day. We use Dask and DaskML, which is a Python framework that's designed for parallel featureization and distributed machine learning. We use Jupyter Notebook and Jupyter Lab to manage our R&D code, and this significantly helps us shrink the gap between research and development. Lastly, we use Jenkins to manage our CI/CD pipeline. Next, I would like to show you guys how we measure the model and what's the quality of our solution of the human in the loop process. So we've done a study with Apigee Media Lab, which is the world's largest media lab. We do analysis on the impact of different content targeting strategy on the purchase intent for our audiences after they watch ads feed by different strategies. We compared 4 different strategies, which are user demographic targeting, YouTube channel targeting, keyword search targeting, and our human in the loop brand suitability targeting. And the result shows that on average, our human in the loop brand suitability process increased the purchase intent of audience by 11%. It's not only statistically significant, but also a lot better than all other targeting strategies. In conclusion, I would like to share with you guys some of the takeaways from this machine learning model that's happening, machine learning process that's happening at ZEFR. First of all, contextual targeting is a hard problem because brand preferences are nuanced, and you need to be really careful when you translate them into surveys because you have to ask the right question, because otherwise you won't receive labels of good quality. Secondly, we don't have great signals in the user part, so all we have is the video metadata, so we have to depend on ourselves and figure out how to generate labels for our model to learn. And thus, we need to define complicated surveys and spend time, do the crowdsourcing, and it's not cheap. You have to spend a decent amount of money to get labels for your model. However, once you get data of good quality, the machine learning actually finds good patterns for your data set, and it can make money for you, not only for you, but also for the brand you're working with. Lastly, I would like to thank all the team members that contribute to the content I'm sharing with you today. And if you're interested in any of the technical details, you can contact me later or any of the other guys on the slides. And that's pretty much it. Thank you.